immersive VR environment for construction detailing education BIM approach. One of the challenges that face architecture education is the link between what students learn and how this can be conducted in reality or constructed in reality, especially with the increasing complexity of buildings and integrating other topics like sustainability and also material complexity. So here comes the role of construction site visits, which play the role of supporting students with the practical experience they need. Despite the importance of the site visits, the inclusion of site visits within a course schedule is not always feasible due to the unavailability of construction sites meeting the intended learning outcomes of certain classes and also time conflicts. In this respect, there is a need for supplementary methods to allow experiential learning for students and further to compensate the inability to fully benefit from construction site visits. One of the significant yet innovative information technology applications in built environment education is virtual construction sites. Which bounces between a semi to all immersive virtual experience that employs some sort of photo or videographic medium for construction projects that might be accessible anytime, anywhere by construction students. As a user-friendly interactive repository of information, BIM can extend the learning environment beyond the classroom boundaries, having the potential to considerably enhance the construction education experience of the students, especially when it's integrated with other technologies like VR and AR. The main research aim is to design and develop a VR application that builds on BIM as a repository of information to develop technology-enhanced learning tool that can be interactive, informative, and gives the students the chance to build in real scale. This is arguably enhancing the learning experience and learning outcomes at the end. To design and develop BIM VR conduit system, we rely on the extracted methods of construction detailing learning, as well as the intended learning outcomes of the BT courses and construction courses in the curriculum of architecture, and also following the learning in virtual environment theory extracted from literature, as long as the technology of VR and BIM. After that, we tried to develop a prototype that has been tested and validated both quantitatively and qualitatively on 3 different phases: piloting, testing, and learning gain validation. The proposed system is designed to support 2 kinds of users: instructors and students, each of which has his own interface and functions that can be done. And there is a processing core in between that can parse and deal with the BIM information in terms of display and associated data, and also control the gameplay and other variables that control the game levels, as well as the feedback to the instructor and student. The repetitive curricular unit is composed of 3 levels that can be applied on different topics. In the developed prototype, which was tested, we were focusing on the masonry construction. There is a building that the student can walk through teleportation and get information on the masonry walls. Then he or she can destroy or go through few details to get information on its components. There are also informative collectibles that should be collected throughout the building. They can explore different layers of a wall and design a wall and get feedback on the thermal performance of this wall. In the problem-solving module, the students find the informative collectibles collected previously to help them solve an introduced problem. After piloting many times during the development phase, the prototype went through testing phases on the level of usability and immersion, using standardized and non-standardized questionnaires. In addition to the qualitative feedback, with the aim to modify certain features and validate a revised version of VR content on the level of instructors or educators, interviews, and also on the students' level. In order to compare the improvement, in order to compare the academic improvement of the students' level on two focus groups, A and B, using VR or experiencing VR and paper-based studying, which retrieved results of 30% improvement for Group A who experienced VR and 13.8 for studying group. In addition also to the learning experience questionnaire to measure the user's satisfaction about this kind of application. The main finding of this research is to design and develop BIM VR content, immersive environment that facilitates experiential learning for construction detailing education. On the level of integrating BIM and VR, this brings construction life to classroom, providing the experiential learning medium for students, and also it has high acceptance among students as well as educators. This requires industry and academia collaboration. On the level of having BIM VR content as a mainstream, this needs reshaping of teaching format, and it has other challenges like lack of reference material, following construction sequence, and also construction educators training. Thank you.